Welcome to the deep dive. Today we are undertaking a truly essential mission, conceptualizing interaction.
Mm-hmm.
We're going straight to the very foundations of design to understand how you define a digital product
Hmm.
before a single line of code is written or a single pixel is placed.
That's right. And for anyone trying to get their head around the mechanics of interaction design, this deep dive is, well, it's your shortcut.
Right.
We're going to unpack the key strategies you need to move from, a vague idea to a concrete, testable blueprint.
And what does that include?
Well, it includes defining the conceptual model, using powerful interface metaphors, outlining the core ways users can engage, and of course recognizing the massive theoretical influences, the paradigms and visions that shape the entire field.
And to kick things off, let's start with a classic scenario that illustrates exactly why this conceptual work is so necessary.
Okay.
The voice-assisted robot waiter in a restaurant.
Yes. The initial enthusiasm for this idea is always based on what we call curative benefits. The designer gets really excited about the potential. Like, it can take orders, it can entertain customers with witty banter, it can memorize everyone's preferences.
We fall in love with the tech right before we really understand the task.
Exactly. The robot is a solution looking for a problem. And the core lesson here is shifting that focus. You have to ask, what is the actual problem we are trying to solve?
Oh, it's not about the cool robot.
It's not. Maybe the restaurant owner's actual problem isn't entertaining customers. Maybe the real constraint is that it's just incredibly difficult to recruit and retain good wait staff.
And that one reframing changes everything. The moment you define the actual problem, say staffing difficulty, your design effort becomes focused. It immediately forces these crucial research questions.
Right, like how intelligent does this robot really need to be to solve a staffing gap? Does it need to move smoothly, or is rolling around okay?
And maybe most importantly, will customers actually like it? Or will they find it gimmicky and distracting after the first week?
Precisely. It turns that kind of blue sky thinking into actionable research. It makes sure you're spending your resources solving the right challenges, not just implementing the flashiest new thing.
Okay, so let's unpack this. The first analytical step in conceptualizing any interaction is the discipline of writing down your assumptions versus your claims.
This step is so fundamental. An assumption is something you're taking for granted, which means you absolutely must investigate it.
So, for example,
Assuming that because everyone has a smartphone, they automatically want a super complex entertainment system built into their car. That's a huge assumption.
and a claim, on the other hand, is a specific assertion of truth that is, open to debate or requires proof.
Right. You might claim that a multimodal interaction style where a user speaks commands or gestures while driving is perfectly safe. That's a bold claim.
A very bold claim. It needs rigorous testing.
We can see how this works in this hypothetical scenario from the source text about a web browser redesign team. They're trying to figure out why users aren't using the bookmarking function, and they start arguing.
Right, one designer might claim, the bookmark function is just error-prone. It's too hard to organize.
But then a software engineer weighs in with a conflicting claim. Bookmarking is obsolete. People just use their history list now. It's quicker.
So they're at a stalemate.
Exactly. But the beauty of articulating these conflicting assumptions about user behavior is that it forces the team to take a step back. They realize their disagreement is all about user intent.
So the process isn't about deciding who's right.
No, it's about forming a concrete, testable investigation. Like, can we simplify the entire process of saving, ordering, and retrieving websites on mobile browser? That question defines the next stage of design.
And the danger of skipping this process, the danger of running on faulty assumptions is measured in billions of dollars of failed products. Let's look at the classic examples, 3D TV and curved TV.
Oh, the failure of 3D TV in the home market is a textbook case of faulty assumptions. The assumption was that the amazing floorback for movies like Avatar in the cinema would translate directly to the living room.
And that people wouldn't mind wearing special glasses or paying more. The claim was this incredible, enhanced viewing immersion.
But the usability problems were just overwhelming. It wasn't just the annoyance of the glasses. It was the social friction.
What do you mean by that?
The moment you put on 3D glasses, you stop being able to see or interact naturally with the person next to you on the couch.
Right. You can't multitask.
You can't. People complained of motion sickness, and you certainly couldn't glance down at your phone easily. That social and physical friction, it just destroyed the concept.
And curved TV.
Curved TV failed because the assumed benefits were trivial compared to the cost. The conceptual model that a curved screen somehow provides a better field of view for the living room, it just didn't deliver enough value. Faulty assumptions, in both cases, proved fatal.
This is exactly why forming the conceptual model early is so important. It's the solution to those faulty assumptions.
And it delivers three massive benefits for any design team. Orientation, it lets the team ask precise, specific questions instead of vague ones.
And open-mindedness.
Yes, it encourages exploration of diverse ideas before you commit to one expensive approach. And crucially, common ground. It establishes a shared language for the team, creating a testable blueprint everyone understands.
And that blueprint, the conceptual model, is just a high-level description of what people can do with product and the concepts they need to understand it.
It's the simple story we tell the user about how this thing works.
And what are its core components?
They're few, but powerful. 1, metaphors and analogies linking to familiar concepts. 2, concepts, so the objects, their attributes, and the operations you can do, like saving or printing.
Okay.
3, relationships, like containment a folder holds a file. And 4, mappings to the user experience. The goal here is just relentless simplicity and memorability.
The best conceptual models literally transform activities.
Yeah.
I mean, think about the classics. The digital spreadsheet, the World Wide Web, and of course, the desktop metaphor.
The desktop, pioneered by the Xerox star in 1981, was so revolutionary because it was based on concepts everyone already understood from the office.
Paper, folders, mailboxes.
Filing cabinets. It was the great democratization of computing. Before that, you needed to master the command line. You had to speak in riddles to the machine. The desktop model suddenly made computing visually accessible and intuitive.
So metaphors are really central to the whole system.
Absolutely. They provide a structure similar to something you already know, but with its own digital properties. A search engine is a perfect example. It invites a comparison to a massive mechanical engine, helping users connect their need to find things with this complex algorithmic function.
And metaphors also manage our expectations.
They do. Take the recycle bin or trash can on the desktop. Logically, if you throw something away, it should go under the desk, right? Not sit prominently on the desk.
That's a good point.
But it succeeded because its visibility provided a safety net. It let users easily retrieve deleted items. We accepted that logical inconsistency for the benefit of visibility.
What's fascinating now is watching how these metaphors are evolving, especially with mobile devices. The shift to the contemporary card metaphor is huge.
The card used heavily in social media feeds and by services like Google now is brilliant because it has these familiar paper-based associations. It structures content into meaningful chunked sections, which is perfect for rapid scanning on a small screen.
And looking to the future, there's a suggestion to frame design goals using two conceptual metaphors, the glasses versus the tool.
Right, and this distinction is incredibly insightful for thinking about how we interact with AI.
So what's the difference?
The glasses metaphor means the technology amplifies human cognition implicitly. You put on the glasses, and the enhancement is almost invisible or subconscious. The system tries to disappear.
But the tool metaphor, like binoculars or a voice recorder, requires explicit conscious interaction.
Exactly. You pick it up, you aim it, you operate the controls, and then you put it down. So if you're building a new AI assistant, is it trying to be invisible glasses, subtly helping your daily tasks? Or is it a tool demanding you consciously operate it every time? That one decision changes the entire interface design.
Which brings us naturally to the actual mechanics of engagement, the 5 core interaction types.
These define how a person engages with any system. They are instructing, conversing, manipulating, exploring, and responding.
The first and oldest is instructing. This is where you tell the system what to do, typing commands, selecting menus, pressing buttons.
It's quick, efficient, and great for repetitive tasks like saving a file or deleting an email.
And you can see the trade-off in instructing when you look at vending machines.
How so?
Well, the simple soda machine is pure instruction. Press one button, get one product, super efficient. But the snack machine, with dozens of options, forces a more complex interaction.
Right, you have to read a code like C7, key it into a keypad, check the price. More options always mean more complexity and a higher chance of error.
The second type is conversing, a two-way dialogue where the system tries to act like a partner.
It's based on our most familiar human interaction, like asking Siri, "Do I need an umbrella today?" And having it interpret your implicit intent, the weather forecast, and respond naturally.
But it can feel natural, but it can also be incredibly cumbersome.
Oh, for sure. Think about those auditory phone menus where you have to listen to a slow, endless list of options before you can finally do what you want.
The naturalness is completely undermined by the system's rigid structure.
Exactly. Our third type is manipulating, interacting with virtual objects by leveraging our physical knowledge moving things, zooming in, dragging a window. This pulls heavily from the principles of direct manipulation.
Which were formalized by Ben Schneiderman back in 1983.
Right, and direct manipulation promotes rapid learning and a feeling of mastery because of its three core ideas: continuous visual representation of objects, rapid reversible actions with immediate feedback, and using physical actions like a drag and drop instead of complex commands.
But manipulation isn't always the best approach.
Definitely not. While it's perfect for dragging a file to a folder, imagine you're writing a 100-page report and you realize you've misspelled a name, like Schneiderman, over and over.
Trying to find and fix that manually by manipulating the text would be a nightmare.
Exhausting and error-prone. A simple command-based instruction, like find and replace all, is way more accurate and efficient. It just shows that no single interaction type is always superior.
Fourth, we have exploring.
This is where you move through virtual environments, using your innate spatial knowledge. This includes navigating 3D worlds, virtual campuses, or complex data visualizations, like KV systems where scientists can literally step inside a data set.
And finally, we get to responding. This is the newest category where the system actually initiates the interaction.
It's proactive and context-aware, and the user responds to its prompt.
Like when Netflix pauses to ask if you're still watching.
Or when Google Lens identifies a dog breed in a photo and immediately pops up relevant information. The system is sensing your context and responding to it.
The challenge here, though, is the fine line between helpful and annoying.
A very fine line. If the system constantly provides inaccurate or irrelevant responses, you just get frustrated, which highlights the need for transparency in its decision-making.
So if we pull back, what are the bigger forces informing all this conceptual design work?
Well, conceptual design is heavily influenced by a hierarchy of higher-level concepts: paradigms, visions, theories, models, and frameworks.
Let's start with paradigms.
Paradigms are the overarching adopted approaches, the shared assumptions that define an era of design. We saw the big shift from the WIM paradigm of the 1980s, windows, icons, menus, pointers, which was focused on a single user at a desktop.
That WIMP paradigm was revolutionary. It replaced technical mastery with visual understanding. And then in the 90s, the shift to the ubiquitous computing paradigm.
Or UbiComp, inspired by Mark Weiser's vision of technology just sort of disappearing into the environment. UbiComp suggested that technology would become ambient, embedded in everyday objects. That evolved into the modern big data and IoT paradigm of the 2000s, driven by sensors, machine learning, and automation. The focus shifted, again, from the individual user to systems optimizing actions on our behalf.
Like smart traffic lights or home heating systems.
Exactly.
Then you have visions. These are future scenarios that frame R&D goals.
Apple's 1987 Knowledge Navigator video is a great example. It showed a tablet interface and a sophisticated speech-based assistant, and it basically set a research trajectory for decades.
And the current pervasive vision is, of course, AI and automation.
Which naturally raises huge concerns about transparency and accountability, the urgent need to explain why AI systems make the decisions they do. We also see how science fiction inspires this, like the Star Trek holodeck, though it's often limited by the author's own cultural perspective.
And to bring all these concepts together, we use frameworks that offer concrete advice. Don Norman's classic framework is probably the most foundational.
It has three pieces: the designer's model, how the system is supposed to work; the system image, how the system is actually presented through the interface and manuals; and the user's model, how the user actually understands it.
So the goal of good design is to use that system image to bridge the gap between the designer's model and the user's model.
You've got it. That's the whole game.
This entire deep dive into conceptualization, it seems to me, ultimately culminates in a critical dilemma for the future of interaction.
Which is?
Who is in control?
Yes. This tension is inherent in the 5 interaction types we discussed. Instructing gives the user maximum control, a feeling of mastery.
But responding interfaces, the proactive, context-aware ones, they take control away from you.
Right, in favor of convenience, automation, or even safety, like systems that monitor an elderly person's movements.
The moment the control shifts, you see these dependencies emerge. Think about GPS navigation.
Okay.
You're in control when you instruct the destination. But once you're on the road, the system takes over. We become technologically dependent.
We often blindly follow the technology over our own common sense.
Totally. The system's convenience often trumps our own critical thinking.
That is a critical psychological cost that we have to design for. So, to quickly recap our deep dive, conceptual models are crucial high-level descriptions. Metaphors aid understanding by leveraging what you already know.
And understanding the 5 interaction types, instructing, conversing, manipulating, exploring, and responding defines exactly how users will engage with your product.
That's it in a nutshell.
And here is a final provocative thought for you to mull over. Given the explosive shift toward autonomous AI systems, the biggest challenge ahead for interaction design isn't just designing the momentary experience, it's designing for the long-term user experience over months and years and on a societal scale.
And that requires methods and tools that the field is, frankly, still racing to invent. A profound challenge indeed.
That was a deep dive into conceptualizing interaction. Thank you so much for joining us.